The future of any business is to be sustainable. Our largest asset is the Co-op Refinery Complex in Regina, and as a result, we have made significant investments in that facility to ensure its sustainability.
Water is critical to the operations of the Co-op Refinery Complex. It is a necessary component in the generation of steam. This steam is used for heating, hydrogen production, and to power equipment at the refinery. Water is also used in cooling towers to regulate the temperature of the refinery processes. Some water is lost through evaporation here. The refinery's water is primarily supplied from on-site groundwater wells. The wells, which draw water from underground, are supplemented by the City of Regina's municipal system during periods of high demand. There is a growing pressure on Saskatchewan's water supply. Population growth over the last few years has increased water demand across the province. Plus, developing industries such as petroleum extraction and potash mining rely on water for their processes. The Provincial Water Security Agency tightly regulates water use in the province for these reasons.
Processing crude oil into finished product, it takes a lot of water. And for us, we recognized a long while back with the Section 5 expansion that we were going to need to do something about being more efficient with our water usage.
We needed to come up with some way of recycling water to reduce the amount of fresh water that we make up.
Well, the Wastewater Improvement Project, we refer to it as the WIP, and that's the project here that's going to make a huge difference. The idea of being able to use a biological technology like this to allow us to recycle water back into the plant and reduce our draw on the municipal system, reduce the pressures on the effluent system. It's one of those situations you look at and you kind of go, it's almost too good to be true.
So we're going to take basically 65% of our water recycle and put it back into the plant for reprocessing. That's unheard of in our industry. And when you look at our vision about being a leader in sustainability, for us to actually reduce water and still maintain operations and actually continually recycle our water over and over again. That's not only good for the environment, but from a social responsibility point of view, it lets that water be used for other people in the city of Regina.
Treating thousands of gallons of wastewater is no small task, and there are multiple stages to process wastewater at the Co-op Refinery Complex. Stage 1 begins at the wastewater separation tanks and oily water separators. Here, floating oil is skimmed from the top of the wastewater and reprocessed within the refinery. Next, sediment and oily sludge sink to the bottom, where they are removed and disposed of safely. The remaining water, with the bulk of the oil and solids removed, continues on to Stage 2. Stage 2 takes place at the dissolved gas flotation unit, where microscopic nitrogen bubbles are introduced into the water. These bubbles help the remaining oil particles float to the surface of the water, where they are removed for reprocessing in the refinery. Stage 3 sees our wastewater travel to the membrane bioreactor. Here, a special formula of bacteria breaks down the biodegradable volatile organic compounds and ammonia in the water, improving water quality and reducing emissions and odors. The water then filters through spaghetti-like hollow fiber membranes called Z-weed to remove suspended solids. This leaves us with a clean, treated wastewater product called permeate. At Stage 4, in order to maintain a healthy level in the bioreactor, excess biomass has to be removed. But this material still has trace amounts of water, so it doesn't go to waste. It's fed to a centrifuge. The centrifuge spins out any remaining water for reprocessing, while the leftover solid biomass is disposed of safely. All the wastewater has now been processed. Odor-causing volatile organic compounds and other impurities have been removed. The wastewater is ready to be recycled in the demineralization plant for use throughout the refinery in a variety of processes.
Currently, we operate a 1,600 gallon per minute demineralization plant on site to meet our needs. It allows us to use reverse osmosis while rejecting the higher organics that'll come from the wastewater. The refinery is going to be able to recycle about 2 billion liters of water every year.
The demineralization plant uses HERO mode to process permeate. This is the water that has been through the wastewater treatment processes, the wastewater tanks, oily water separators, dissolved gas flotation unit, and membrane bioreactors. This permeate contains higher levels of dissolved solid organics than raw water and needs extra purification before it can be used in steam production. Upon entering the demineralization plant, permeate passes through filters, which remove suspended solids. Next, ion exchange units remove hardness or soften the permeate water to avoid scaling inside any equipment. Then, a forced draft decarbonator uses air to strip corrosion-causing carbon dioxide. The conventional reverse osmosis system uses hundreds of semi-permeable spiral membranes to remove remaining dissolved solids and organics from the water. In hero mode, the clean permeate from the first reverse osmosis unit is sent to a second identical unit for further purification. Finally, a mixed bed ion exchanger provides a final polishing step to remove all undesirable ions like calcium, magnesium, sulfates, and chlorides from the water. The resulting water product is pure enough to be used throughout the refinery. When the plant is fully operational, the refinery can reuse approximately 1,500 gallons of wastewater per minute, or more than 2 million gallons per day. Leading-edge technology and vast scale make the Wastewater Improvement Project a foremost example of water reuse worldwide.
We're trying to recover every drop of water that's reusable. 1,500 gallons a minute coming at the Demin plant. It's a phenomenal impact on reducing our water footprint.
We need to do what we can. We need to make those kind of investments. Improvement of the quality of the air, improvement of quality of life in the community, reduction in use of water inputs, reduction in use of effluent outputs. It doesn't get much better than that. Where we have water scarcity issues, which is a large part of North America, this project is going to be very much of interest to those folks.
With a fully operational wastewater improvement project, the Co-op Refinery Complex's reliance on raw water from the city or aquifer will decrease by the equivalent of 3,100 households in Regina on an annual basis. In addition, less wastewater will be discharged from the refinery to the city's wastewater treatment plant as it continues to be reprocessed and recycled. Air quality will improve as the Wastewater Improvement Project will significantly reduce odor-causing volatile organic compounds and other emissions being emitted into the atmosphere.
The people that live closest to the refinery in the past have had issues with the nuisance odors that come off of our wastewater ponds. So this project goes a long way to reducing those odors.
When the Wastewater Improvement Project is fully operational, the Co-op Refinery Complex, according to industry experts, will be the only refinery in North America that can clean and recycle all of its wastewater for the purpose of steam production.
In our vision, what we want to be is that leader in safety, reliability, and sustainability.
We can not only increase production, but we can actually reduce the amount of water we're going to use. That's an enormous win for everyone.
Our refinery uses a lot of water, and to be now in a position where we can recycle that water and remove part of the demand from the city of Regina, from the province of Saskatchewan, and frankly from Canada, is our small part in ensuring that this planet has a brighter future.